Hello class, this is your Professor Joseph Holbrook for Introduction to Social Science, and today we're talking about Chapter 6 in Hunt and Colander, Technology and Society, an important part of the social experience. So let us begin. What is technology? Technology are the tools, the means, the methods that humans use to interact with their environment. Technology is very important to culture. It causes social change. It's influenced by culture. An example would be the impact of food canning and refrigeration in the middle of the 19th century. The Industrial Revolution began in England around 1760. It was a significant change in human culture and civilization. It was characterized by the replacement of hand tools with power-driven machines. Improvements and inventions in one area led to changes in related industries, and this tended to have a synchronous effect, which every improvement, every invention sped up the process of change and led to more inventions and improvements. It feeds upon itself in sort of a positive cycle. It gave English production a significant world advantage over other countries, and industrialism began a worldwide expansion at that time. This is a picture of some of the cities where industrialization began early on the European continent, particularly in Germany, Belgium. You see there's several cities that were emerging industrial centers. The Industrial Revolution came very quickly to the United States, and the United States followed closely behind Great Britain and eventually caught up. Early in the 19th century, the machine industry and factory system developed in the United States. Much of the technology borrowed from the Great Britain. The United States had a protectionist economy at that time, restricting textile imports, which helped protect the incipient U.S. industry for textiles and created growth opportunities in the United States. The textile industry successes led to the spread of industrialism in the United States. The United States had several significant advantages. It had a huge internal market, plentiful raw materials, and it provided good wages for workers. Some key concepts in technology, and especially in industrialism, are standardization, interchangeability, and mass production. In standardization, it's possible due to improvements in the specificity of measurements. The needs of the armed forces often drove changes. In the early part of the 19th century, railroads in the United States, every railroad had different gauge rails, so that one railroad rail line or one rail engine was not able to travel on another company's rails. And so at some point the Congress required them to standardize their rail sizes so that trains could go on any rail system in the United States. Interchangeability is another concept. John Hall was the designer of precision machine production, and he developed this idea of interchangeability of various parts. So if one part broke, you could just immediately replace it with another identical part. This accelerated the pace of change in the Industrial Revolution. Also, Henry Ford, the inventor of the Ford automobile, developed the concept of the assembly line production or mass production, in which each worker only did one repetitive action as the product moved along the assembly line. The Industrial Revolution and the rapidly increasing pace of technological change had significant social effects. For one thing, the status of workers declined. Workers went from being artisans and masters of a craft, for example, shoemakers making shoes by hand, to becoming just one cog in a machine on an assembly line, and not ever quite seeing the entire product, but only doing one part of the process. The owner's status rose. Owners gained greater power. They accumulated wealth and capital. This was the incipient beginning of capitalism. The newly rich industrialists moved into society, bringing new social values that were business-related. Also, war increased. Armies and weapons cost significantly less when you can mass produce rifles or other sorts of armaments. Here's a picture of Manchester, England during the early phases of the Industrial Revolution. You see all the smokestacks spewing out pollution. Normally, when a country is in the early stages of industrialization, there's a lot of pollution in the beginning. Social change and the Industrial Revolution continued. The invention and production of low-cost cars removed geographic restrictions, which allowed greater migration. Cities were able to grow larger. People moved to the suburbs because they were able to travel more effectively to their jobs with their automobiles. Low-cost tools increased farm productivity. So you had less and less farmers producing more and more food, and the cost of corn, wheat, and farm products continually moved lower, which was good for the consumers, but drove many farmers out of business. There were fewer farmers needed, and the cities continued to grow as a result of the Industrial Revolution. It also impacted traditional male and female roles. There was more of a need for workers, and so there was a great pressure for women to go to work in factories. And as time changed, you eventually had the two-income family becoming the standard, with children in school or daycare, or often latchkey children in the 20th century. This also gave greater independence to women. If they're able to leave the home and earn their own income, it made them somewhat less dependent upon their husbands. Technology and globalization. So globalization feeds off of the process of technological change. They kind of go hand in hand. Specialization and trade increases. Transfer of production facilities. For example, in the 1990s, many of the Detroit automakers building Fords and Chevys and GM cars moved their production facilities to Mexico or China or Brazil, where they could hire workers to build their cars at a much cheaper hourly or daily rate with less benefits. The internet speeds up the globalization process. There's a shift of routine jobs from human beings to machines. I remember when in the turnpike in Miami we had actual human beings collecting the tolls. Then we went to a SunPass system, and now you don't even see the toll as you drive through it. It's all become automated. Specialized skills are in demand. We live in an information society or economy, and so more and more people have to get an associate's degree or a bachelor's degree and have to specialize in certain specific trades in order to develop the specialized knowledge and skills that are needed in this economy. A question that must be asked is, should growth be limited? The economy is driven by wants and resources. The technology holds the key to growth. It also can provide a solution to shortages. Will the world run out of resources before resulting pollution destroys it? For example, the Industrial Revolution and vast technological needs have caused us to use petroleum. Some people are very concerned about the use of an oil-based energy system that creates global warming, but probably our best hope for developing alternate sources of energy, clean energy, comes from technology itself. So as we grow technologically, we may be able to find solutions. Culture is shaped by resource availability. This is true in the growth of cities. I've already mentioned the concerns and dangers of global warming and the social and political effects that may come from that. Some people are saying that the heavy increase in migration in the Mediterranean and in the South China Sea is due to changing weather patterns from global warming. Some significant technologies of the past included human teeth, hands, the human brain, fire, wooden shelters, spears, bows, and arrows. Culture change speeds up as human reasoning develops and tool making progresses. For example, in the late Roman period and the early medieval period, a major technological breakthrough was the invention of the stirrup. You would not think that something so simple as a stirrup on a saddle on a horse would be a significant technological development, but the whole culture of medieval jousting and knighthood depended on being able to hold oneself securely in a saddle and not get knocked off, and to do that required a stirrup. Also, the Mongol invasions, Genghis Khan, their success had to do with their ability as a fast-moving cavalry and their ability to stand in their saddles on their horses and shoot bow and arrows as they were riding, and that required stirrups. What about the future? There's constant improvements in everyday machines, improvements in computer technology, biotechnology, nanotechnology. The only certainty is change, social, economic, and cultural. In 2005, Ray Kurzweil wrote a book called The Singularity is Near, When Humans Transcend Biology. It's a non-fiction book about artificial intelligence and the future of humanity. And he has some pretty amazing predictions about the increasing of computing power and the ability to map the human brain, and perhaps even to copy the human brain and download it into software. This is what he calls the singularity. It's a moment in time which the technological change takes off so rapidly that we cannot imagine or speculate about what's on the other side. So our book calls this the Anthropocene Age, or the Age of Man, which began with the Industrial Revolution. Geologists argue that this new age is needed to reflect the significant feedback of humans' interactions on the geology of the world. Others argue that if the term is going to be used, it needs to extend back more than 12,000 years ago to the agricultural revolution, making it synonymous with Holocene or entirely recent. So here's a timeline of the future. We're already in 2015 now, and there's breakthroughs in medicine, methods of delaying aging processes. World population increases in about 10 years. There's a prediction that there'll be developments with redefinition of matter. Diamonds and metals will no longer be scarce. 2030, fusion reactors may be created that makes energy too cheap to meter. Oil companies may go broke. 2040, genetic engineering means fabricated human replacement organs will roll off the assembly line. Of course, this is all speculative. Amputated limbs may be regrown. 2045, human cloning may be perfected. All parts of the body can now regenerate themselves. 2050, computer chips developed to place in the human head eliminates the need for teaching. That will put me out of a job, but I shouldn't be around by that time. And it continues with temperature rising on Earth, Miami going underwater, various complicated life forms reproduce from organic chemicals, significant debate about morality and the meaning of life. We already have that now, and etc. 2280, the Starship Enterprise returns safely to home base. A little bit of humor there. And here's a picture of the exponential growth of computing power in the 20th through the 21st century. So you see that we are almost at the point that we can develop, we have computers that are equivalent to a mouse brain, but in a few years there'll be computers that will be equivalent to a human brain, and then eventually all human brains. And that would be the singularity. So I hope you enjoyed this chapter on technology and society, and I hope you'll read the chapter in the book, and we will discuss it this week. Thank you very much.